something out because I can only do so much. Okay, woo. I'm grabbing a calculator. I suggest you have one. For the first part, we're just converting a few degrees to radians. I highly suggest you try to keep this paper neat. The reason being is we use it a lot, and the neater it is, the less confusing it is, basically. Okay, so we want to convert degrees to radians. So 0 degrees is just 0 radians. That one's always easy. So when I see 30 degrees off to the side, remember, keep your paper neat, or on a separate sheet of paper or in your calculator. Just a reminder of how to convert degrees to radians. We're going to take 30 degrees and we're going to multiply it by pi over 180. All right. And once I do that, remember, I need to reduce this. So the degrees cancel. I end up with 30 pi over 180. And then I just use a calculator and I reduce this fraction, the 30 over 180. And the calculator will do it right for me. And that will come out to 1 over 6. So we leave it in terms of pi. So next to 30 degrees, I'm just going to write that as pi over 6. Or if you can write 1 pi over 6, that's also perfectly fine. So our main goal, I'll do the next maybe 2 with you, and then I'm going to have you guys try a few. Is we need to convert these because we know, or hopefully we know, maybe-ish. With circular functions, it refers to radians. So the degrees are great, but they don't really help us. So if we convert these to start, then our life is going to be easier in about 10 minutes here. So once again, 45 degrees. Literally, I'm going to keep just doing the same step. 45 degrees times pi over 180. That gives me 45 pi over 180. And then I'm going to reduce this using my calculator. So I'm just going to, remember, you don't put the pi in when you reduce. 45 over 180. Oops, I hit the wrong button somewhere. 45 over 180 is 1 pi over 4. Okay. Came out to 1/4. I just threw that pi back in. So I'm just going to write that as pi over 4. You don't need to write the 1, but you're more than welcome to if you'd like to. Okay, I mean, literally, we're just going to keep doing this. And you can do it right in your calculator. So as we get used to it, here's what I usually just do. When I see this, I'm just reducing 60 over 180. I'm not even going to really write the steps out. So I just go to my calculator, 60 over 180, and I reduce it. And that would be 1 pi over 3. So it comes out to 1/3. I throw that pi back in. And I get pi over 3. Right now, can everyone convert 90 degrees while I got it in front of me? Yeah. Oh, yeah, there's something else. 90 over 180, they should take about 10 seconds each, because remember, the work is done in the calculator, you just need to know what you're multiplying by. But make sure that radian column we are correct. If not, it's going to be convinced. Oh, in a few minutes. Excuse me. Goodness gracious. So this is all you're doing. 90 times pi over 180. So I'm going to save myself some steps just by kind of reducing that, right? 90 over 180. So I can do that in my head. That's just pi over 2, right? Is 1, it comes out to 1 over 2. So 1 over 2 pi. So I'm just going to write that as pi over 2. So we have all of the angles from the first quadrant. Delightful. We'll do one quadrant at a time. So I'll give you a few seconds to make sure you have those written down because you're going to need them in a minute. Okay, so let me scroll a little. We'll go to kind of the next quadrant. We'll do a quadrant at a time. Doesn't really matter. I'll just do a few at a time. Okay, so now we have the next little, I don't know, few that I can see at least. So let's focus on from 120 to 180. We'll just do a few at a time. So right now, can you convert these to radians? And just as a reminder, you're going to multiply by pi over 180. And reduce. So I'm going to take attendance while you guys are trying those ones. Oh, shoot. I'm going to do my best to take attendance. Computers. I'm going to do your attendance in a few minutes. Hold on. I just can't do it right now. So I know there's a big old light in the middle of your screen at home. Sorry about that. It's just the way the projector is. But it's just filling that one column now, and I'll put the thing down in a few minutes. I go right onto my Google with my phone. Good morning. Just make sure you grab one of those charts over there. All right. I'm going to be trying to join to my phone, but I'm on YouTube. So we're just converting a few. They should be pretty quick, especially if your calculator handy. Remember, if you don't have a calculator handy, there's that link for Desmos, and it will reduce all your fractions for you. So just as a reminder, I'm just going to go there, just to show the people at home. I go to that Desmos. That's not our Google Classroom. I'll go to Google Classroom. It says don't have a scientific calculator, just click on it. And then if you have to do 135 over 180, you just do literally 135 divided by 180. And then over here, it will give you a decimal, but then we want it as a fraction, so you just have that convert to fraction. So this calculator is useful because it will kind of just do it for you if you don't have one. Or the phone one's kind of stink, I'm going to be honest. So this one's good because once again, that fraction thing is your friend, and it will convert everything to fractions for you. Oh my gosh, where am I? All right, let's check those few. So we'll kind of try a few, check a few, see how we're doing. The main goal is to fill that in. And I'm going to show you some shortcuts for what we were doing last week. So I'm just grabbing my calculator. I'm not going to show my workout. And this one, I'm just doing 120 over 180 and reducing it. And that should come out to 2 pi over 3. Remember that pi is there. I think I just did that one, but I'm just going to recheck myself. 135 over 180 is 3 pi over 4. 150 over 180, so I just keep redoing the same step, is 5 pi over 6. And 180 over 180, I can do in my head, is just 1 pi. Where's pi? I don't really need to write the 1, I guess. Okay, so they weren't bad. And actually, I'll get it up in a minute. If we look at the unit circle, those are the same points that were around the unit circle, so those were the points in quadrant 2. So take a second to check those ones, but this chart's going to be your best friend, so just make sure you have the right values. And that's why I filled in all the other stuff for you. So technically, you guys had filled this in earlier in the year when we were doing some degree stuff. But I don't think we ever actually really full on checked it, so I said, I'll just go through and make sure you have all the right values. Make sure your radian column is correct. All right, I'm just gonna help you with the rest, because if not, I feel like we just kind of sit here in silence and I go a little crazy. So I'm just gonna move it down. Oh, we only have, oh, I kind of moved it a little bit, but. So for the next few, this is kind of the third quadrant. Once again, I'm just gonna grab my calculator. I'm doing the same step over and over. I just keep doing the same thing. So each degree, I'm gonna divide by 180, because I'm technically multiplying by pi over 180, so I reduce that fraction, and I just put my pi with the answer. So this is 7 pi over 6. For 225, it comes out to 5 pi over 4. Again, just reducing it right in my calc. 240 is 4 pi over 3. And 270, what would that be? 3 pi over 2. Okay, so that was quadrant 3. I'll leave those ones up for a minute. And then we'll do the last quadrant. All right, so then the last few we had quadrant 4. We can finally use this thing. I'm just gonna kind of read this baby up so I can actually put everything. All right, so our last quadrant, whatever you want to call it. We already did 270, so we're starting at 300. Super quick, so bear with me. 300 over 180 is 5 pi over 3. 315 over 180 is 7 pi over 4. Okay. 330 is 11 pi over 6. And 360 is 2 pi. All right. Delightful. So now I'm going to show you like why do we want this, how do we use it if I ask you something about a circular function. But now it's all filled in for everyone. So that will be introduced to you in a moment. So I'll give you a second if you're still writing. Alright, I'm going to kind of put two things up on one. Let's see if I'll actually be able to see both of them. I'm going to put up the unit circle, which we were talking about the other day. Okay. Oh, I think I just did that one on. Unit circle. All right, we got this. So if you go to images, there's like 8 million images. I think we're using this one. That thing is drawing on speed, but we'll go with it. Okay, so I'm going to put that on one half. And then the other half, I'm going to put my chart. I actually have all my things filled in. I'm going to do that nice and just give it to you. So let me find that one. Okay, there we go. So I'm going to put that on my other half. All right, so we have a unit circle. We have our chart, which I know you can't see the whole thing, but that's okay. I can kind of move around as I need it. Just so like people at home can see. So last week, I would have said, oh, can you find the value of the sine of 4 pi over 3? And you would have had to find 4 pi over 3. You would have had to remember that sine was equal to y. You'd have to find the y, and then you'd have to give the answer. So that one wasn't even that bad. It was more when you were doing ones that you had to divide that was kind of a pain in the butt. But now, if we just say sine of 4 pi over 3, you literally are just going to go to the chart. And I know the people at home can't really, this isn't the best thing, but you get the idea. You find 4 pi over 3, which is right here. It's the same as 240. And literally for sine, you would just look in the first column, and you would just write negative square root of 3 over 2, which was the same answer. So for sine and cosine, they weren't bad, but for the other ones, they were kind of annoying. Fractions, everything simplified for you in the chart. So now, if I say something like, what's the tangent of 5 pi over 6, you literally just go to tangent, column, 5 pi over 6, and you write the answer, and you're done. So I'm not going to torture you with doing all the fraction stuff, because what's the point of this? At this point, I don't want to make life too terrible. So if I said, what's the cosecant of 120, you would just go cosecant, I wouldn't say 120, I would say the cosecant of 2 pi over 3. You would say cosecant, you would find 2 pi over 3, and then you would just give me your answer there. So that would have been one where you had to do some dividing, and it would have been annoying. So once again, I'm not going to torture you with that. So your chart is going to be your friend. This chart is on Google Classroom, but you will have to fill in the radian column. I'm not being that nice to you. There's a bunch of other stuff on the back. I have to decide what we're gonna do next. So we might use those, we might not. I have to kind of go through. We're definitely skipping the graphing chapter, because I don't think we have the energy for that. But I'll kind of decide what we're gonna do after we do radian stuff. Okay, so what I'm gonna do now, you're going to have your chart in front of you. You're going to be using it. I'm going to not have this up anymore. So using your chart, I'm going to say. Can you find these values? Ready? So if I say find the exact values. Okay, and I'm going to say, I should have written down all these things. Sine of 2 pi over 3. Cosine of 11 pi over 6. We'll do one of each. We'll do tangent of 5 pi over 4. So right now you're saying, oh, wait a second. I literally have to do no work anymore. So we should be enjoying this chart here. So I'm just trying to find some different values. We'll do 3 pi over 4. Have I done that yet? Okay. Cosecant of 3 pi over 4. We're going to do the secant of 2 pi. And the cotangent of 5 pi over 6. So whereas last week you would have said, oh, sine of 2 pi over 3. Go to the circle, find 2 pi over 3, find the point that goes with it, figure out what you need. Now you should have your nice shortcut using that chart. So can you find those values for me? Well, I know it's I'm all thrown off this morning. Looks cool. Let's see who's here. Check on you. Okay, so literally that should have maybe taken you like 20 seconds. So you're just looking things up now. aligning my chart with the values because Mrs. Sherman's a dodo and actually didn't ever print one for herself. So I literally am just going through, so I'm looking at my chart on my computer because I never actually printed the one with the radians on it. So I find 2 pi over 3, I just find that column, okay, 2 pi over 3. And then I find the sign and it should be root 3 over 2. Okay, so that's a lot easier than, even though these were the easy ones from last week, it's still less work. Cosine of 11 pi over 6, so I got 11 pi over 6. Cha, cha, cha. And that's also root 3 over 2. What do you know? So we see a lot of these have the same values, because once again, there are only so many options when you have those special right triangles. Tangent of 5 pi over 4 is just 1. That was easy. Cosecant of 3 pi over 4. Where is it? I have square root of 2. Secant of 2 pi. I need to put one on these. C is also 1. Okay, so we see a lot of times we have the same answers. That's perfectly fine. And then cotangent of 5 pi over 6 is negative root 3. And we're done. So have that chart. Use that chart. It will make your life easier. It will make less work for you in the future. And the next thing we do after this, you literally need the chart for. You need to look up values. So please always have it with you and have it handy. Are there any questions with those problems? All right, I just want to do one more. That's it. And people at home, I'm gonna kind of check in that you did that. People here, same thing, because I give you credit basically for being here every day. So please make sure you're doing what you need to do. And then we'll be good. So I'm gonna say, can you find the sine of 19 pi over 6? And then you're gonna say, well, when I look at my chart, there is no 19 pi over 6. So we were doing some of these last week. When you are looking at your chart, if you don't see your value in the radian column, that means for this, we need to find a coterminal. Hey, does anyone remember from last week? When it was degrees, we added or subtracted 360. When it was radians, does anyone remember what we add or subtract? 2 pi. It's 2 pi. So for a coterminal, you add or subtract 2 pi. If you look next to 360, it's 2 pi. That kind of makes sense. So this is too big, right? There's too many rotations around. So I'm going to take 19 pi over 6, and I'm going to subtract 2 pi. And I want to make it a smaller number. Remember when I'm doing this in the calculator, I'm just doing 19 over 6 minus 2. Don't put the pi's in because it makes it all sorts of messy. We just want an exact value that we can look up. So we have 19 over 6 minus 2. You can use that Desmos one, or if you have a scientific one, go for it. And that's going to give me 7 over 6. And I put that pi back in. So now I just remind myself, oh, well, I'm just really finding the sine of 7 pi over 6. And then I can just look up right in my chart. The sine of 7 pi over 6 is negative 1/2. And then you'd be done. But just as a reminder, we have that chart because between 0 and 360 is one rotation. You can have more than one rotation, and that's perfectly fine. You just might need to find a coterminal. Same thing goes for negatives. If you have a negative, you would add 2 pi. I need to look at a few things in a second. Okay. So here's what I want you to do at home.